Guys, hope you're having a good evening. Get this full screen mode. This is the notes for factoring using the distributive property. So we're going to distribute. A lot of this you've done and kind of build off what we did yesterday or today in class. So I'm going to, that's too much. Okay, here we go. Hopefully you can see this. You should have the sheet in front of you. First, just review. It says to simplify. All we need to do is distribute. So we're doing this times this times this, and this times this. See, there's three terms here. There's 5x, there's 3z, there's 2y to the fifth. There's three different terms, so we got to distribute out evenly. 6 times, so the first one we did is 6 times -5, which is -30. We got x squared times x, that's going to be x to the third. We have y to the third. There's not a y here, so that's just going to stay y to the third. Alright, then we go on to the next one. So we got plus 6 times 3 is 18. X squared times, there's not an x here, so that's just going to stay x squared. There's not a y right here, so that's just going to stay y to the third. And z will just stay z. And we got one more to do to multiply these out. So we got plus 6 times 2 is 12. X squared, there's not an x here, so that's going to stay x squared. Y to the third times y to the fifth, that's going to give us y. 3 plus 5 is going to be y to the eighth. And there is your answer. Greatest common factors is what we did yesterday. Here's your 3. We want to break these down. So if you want a good way to do this is to separate them. Give you some space. Let's break this down. 12. That's 2 and 6. And then 6 breaks down to 2 and 3. So the numbers are 2, 2, and 3. If you want to put dots between them so you know those you're multiplying right there, that's good. X's, there's 5 of them. So you have 1, 2, 3, 4, 5. Y's, there's 2 of them. 1, 2. Z's, there's 1 of them, and you have a Z. By doing this, you can see and clearly see how they're going to match up. So if we do the next one, I know 14 is going to break down to 2 and 7. So our numbers are 2 and 7. X's, there's 3 of them. So 1, 2, 3. Y's, there's 4. 1, 2, 3, 4. And Z's, there's 3. 1, 2, 3. Last one, break down that 15. That's 3 and 5. So that's our numbers are 3 and 5. X's, there's 2. Y's, there's 3. 1, 2, 3. And Z's, there's 4. 1, 2, 3, 4. Alright, now, what do they have in common? I'm going to switch colors here. Maybe it'll help us see it. What do they have in common? 2's. Okay, these have 2's, but this one doesn't. Okay, 3's. There's a 3. No 3. Okay, 5, 7. They don't have any. So there's none in common. Again, they all have to have one. X's. There's 2 X's here. 2 here. 2 here. Okay, so we got 2 X's. Y's. There's 2 here. 2, 2. Z's, there's only 1 here, so 1, 1, and 1. Okay, so the ones we underline 2 X's. So I'm going to say X squared. How many Y's? We got 2 Y's, so that's Y squared. And then Z's, there was 1 Z, so that's Z. That would be the greatest common factor. Alright. Remember, factors are the terms that are multiplied. Use a little text, maybe this will work. Multiplied. Okay. Get my red pen back going. To make a product, find the missing factor. So we got to set this up as this times something equals this. So we're trying to find it. 6 times what is 24? Well, 6 times 4. Okay, a squared times what is a to the 5th? Well, a squared times a to the 3rd. Because 2 plus 3 would be 5, which would give me a to the 5th. M times what gives me m to the 9th? Well, m times m to the 8th would give me m to the 9th. There's the missing factor. Same thing here. This times something gives me the answer. All right. 5 times something gives me negative 25. Well, 5 times negative 5. X to the 3rd times something gives me x to the 4th. I'm just needing one more x, so just multiplied by x. Y times something gives me y to the 6th, so that's going to be y to the 5th. Pretty easy the way they're set up. Okay. Right here, we're going to use our distributive property, which we've done before. We've used that before. We're going to find the greatest common factors of all the terms. And when we do this, your greatest common factor is going to go on the outside, and what goes on the inside is the remaining factor parts. I'll show you what that means. Okay. So again, here's the step we're doing. We're going to find the greatest common factor of all the terms. It's what's going to go in front of the parentheses. The remaining factor parts go inside the parentheses. So whatever's left will go inside. And then remember, you must have the same number of terms in the parentheses as you had in the original polynomial. So here we go. Example. 3x times something gives me 12x squared minus 18x. So this has two terms. So I know there's going to be two terms in the parentheses. All right. 3x goes on the outside. That was given to us in this problem, but I know it's 3x because the greatest common factor between 12x squared and 18x would be 3x. Negative 3x. So they gave me negative 3x. So negative 3x times something gives me 12x squared. Well, it's positive. Negative 3 times negative 4 gives me 12, and then x times x gives me x squared. So there's the first term. We have another term. Negative 3x times something gives me negative 18x. Well, I know it better be positive because the negative times a positive gives me negative. 3 times 6 gives me 18, and then x is x, so it's good. So what goes in the parentheses here is negative 4x plus 6. If you want to think about it like this, we could have said negative 3x times something is going to give me the first term, which was a positive 12x squared. And that's where we got our negative 4x. And then we have negative 3x times something gives me our negative 18x. And that's where we got our 6. Our two terms. 2 terms. Next page. Just a few more examples. 4 more examples doing this. So we're going to use the distributive property. Again, the first thing we want to do is find the greatest common factor of these terms. So here's one term. Here's the other term. We're going to find the greatest common factor. So if you break this down, that's 3 and 5 and an x. This would be 5, a 5, and 2 x's. So the greatest common factor would be, if I get my blue, would be a 5, an x, and an x. That'd be 5x. Okay, then we have our parentheses. 5x times something. I'll write this out. 5x times something is going to equal our 15x. 5x times something equals 15x. 5x times 3. So 3 is the first term. Second term, again, 5x times something equals 25x squared. Five x times 5x. So that's going to be a plus 5x. And that would be our answer. Alright. I'm going to do the same steps on these following ones. First thing you got to do is find the greatest common factor. Find the greatest common factor. So I know that negative 8 goes into negative 24, so I'm going to say that negative 8 is the number. B, they both have a B in common. C squared, C, they both have one C, so a C. There's your greatest common factor. Set your parentheses up. Negative 8bc times something equals negative 8bc squared. So all I got to put right here is a C. Multiply those together, and that's going to give me C squared. Alright. Negative 8bc times something gives me negative 24bc. Well, it's going to be a positive 8 times 3. So that's a 3 to get 24. B, C, C. So it's good. C plus 3, that is our answer. Alright. C, what is our greatest common factor? Well, this is a 2 and, and 2 x's. This is a 2 and a 3 and an x. This is a 2 and a 2. What is our greatest common factor? Well, there's a 2 here, a 2 here, and a 2 here. That's all it is. So a 2 is going to go out front. You got your parentheses. On this problem, there's 1, 2, 3 terms. So I'm going to have 1, 2, 3 terms. 2 times something gives me 2x squared. Well, 2 times x squared gives me 2x squared. 2 times something gives me 6x. Well, I know it's going to be positive. They're both positive. 2 times 3 gives me 6, and then x, just bring the x with it. 2 times something gives me 4. Well, I know 2 times 2 is 4, so the last term would be 2. And there is the answer. Same steps for D. Find that greatest common factor. So we break this down. This is a 2, a 3, an A, and 2 B's. This is going to be a negative 1, a 3, and a 5. 2 A's, 2 B's. And the last one, a negative 1. And then you have 3, 3, and 3. Because 3 times 3 times 3 is 27. You have 1A and you have 3 B's. Now, what do they have in common? 2 B's, 1A. Okay, let's see if they have anything here. Okay, a 3. We got a 3, a 3, and a 3. So I see that we have 3, and then we said 1A, and we had 2 B's, so that's B squared. Set your parentheses up. I'm going to just do all the steps right here, everything we've been saying. So we have 3A B squared times something equals 6, this first term right here, equals 6A B squared. Well, 6 times 2 gives me 6. 3 times 2 gives me 6. A times A is good. A is good. B times B, so we need a B to give me B squared. So the first term is going to be 2B. All right. Same steps. 3AB times something is going to equal negative 15 A squared B squared. That's a 2. 3 times Negative 5 gives me negative 15. A times, okay, we need another A right there to give me A squared. And B, we need another B to give me B squared. So what goes here is minus 5 AB. Last term, we got 3AB times something. Gives me the last term, which is negative 27. A, what's an A? B cubed. All right. 3 times a negative 9. A's are good. B, we need B squared, because B squared times B would give me B cubed. So this is going to be minus 9 B squared. I forgot to put B squared. Sorry, guys. I was trying to figure out where I went off right there. There should be a B squared in here. So this B should be gone. This B should be gone. And this should just be B. Sorry about that. So that should be gone. That B should be gone. And this squared should be gone. So it should just be 2 minus 5A minus 9B. Where I made my mistake when I wrote my greatest common factor down, instead of putting the B squared, I just had it B. So I was factored in that I need another B. Well, I didn't. The reason I identified that mistake is there was a B here, there was a B here, and a B here. They all had a B. I could have factored out another B. But my mistake was I forgot to put B squared. All right. Okay, guys, we'll go over these tomorrow. Hope you have a great evening.